Let's have a look at the example how we can use two samples to make some conclusions about two population means. Suppose two random samples of 100 obese people each are selected, and one group of 100 is placed on the low-fat diet. The other 100 are placed on a diet that contains approximately the same quantity of food, but it is not as low in fats, carbohydrates, and cholesterol. For each person, the amount of weight loss or gained in a 3-week period is recorded. The average weight loss in the first group is found to be 9.31 pounds with standard deviation of 4.67 pounds. And the average weight loss in the second group is found to be 7.4 pounds with standard deviation of 4.04 pounds. Form a 95% confidence interval for the difference between the population mean weight losses for the two diets. Interpret the results. So from that exercise, we can get the following information. So we've got two sample means, x1 and x2. So the first sample mean is 9.31 and the second sample mean is 7.4. We also know two sample standard deviations. So the sample deviation in the first sample is 4.67 and the sample deviation in the second sample is 4.04. We also know the sizes of two samples, and they are equal, 100 and 100. We also know the significance level because we are asked to specify to construct 95% confidence interval. So 100 minus 95 gives us 5% significance level, or 0.05. And given this, we can obtain the critical z-score. That would be the z-score at level alpha divided by 2, so 5% divided by 2, which means that we need the z-score at 2.5% or 0.025, which we can easily get from the table, and it is equal to 1.96. So that's the formula for the confidence interval when we do not know the true populations variances, we only know sample variances. And when we substitute everything into the formula, we get the following. So x1, so the first sample mean is 9.31, x2, the second sample mean is 7.4, the critical z-score is 1.96. The first sample the sample variance is 4.67 squared and 1 is 100, plus the second sample variance, which is 4.04 squared divided by the sample size 2, which is 100. So we get that the confidence interval lies between 0.69 and 3.13. So we can conclude the following. We're 95% confident that the mean weight loss for the low-fat diet is between 0.69 and 3.13 pounds more than the mean weight loss for the other diet. In other words, we can say that we can be 95% confident that the true population difference between the two means lies between 0.69 and 3.13 pounds. Let's continue working with this example and let's see how we can determine if the low-fat diet is more effective than the regular diet. And to do that, we will use a 5% significance level. So as always, we start by formulating the null and alternative hypothesis. The null hypothesis is that the two population means are the same. So if we move mu2 to the left, we will get that mu1 minus mu2 is equal to 0. So the difference between two population means is 0. And the alternative hypothesis is that the first population mean, so the weight loss in the first population is higher than in the second one, or if we move mu to the left, we'll get mu1 minus mu2 is higher than 0. As we can, based on the second hypothesis, so based on the alternative hypothesis, we can conclude that this is a positive one-tail test. We use 5% significance level. So we will need the critical z-value at the significance level of 5%, which we can easily get from the table, and it is equal to 1.645. So when we put everything into the formula for the z-score, we get the following. So x1 and x2 we already know, those are the sample means. D0, this is the value specified in the null hypothesis, and in the null hypothesis we assume that the two population means are the same, so D0 is equal to 0. And then we in the denominator, we put the square root, under which we put the following value. So S1 squared, this is samples 1 variance. N1, this is its sample size, which is 100 people, plus 4.04 squared, this is the variance of the second sample, divided by 100, which is the number of observations in the second sample. And we get that the estimated z-score is 3.09. So to make a decision, we compare the estimated z-score with the critical one, and we can see that the estimated one is higher than the critical one, which means that we should reject the null hypothesis and accept the alternative hypothesis that the difference is actually positive. So at 5% level of significance, we can conclude that there is sufficient evidence to conclude that the mean weight losses for the two diets differ. So, or in other words, at 5% level of significance, we can say that the first diet of the low-fat diet is more effective than the second diet.